All right, so indicator 16, day 2, we are going to continue with our story problems. And because of the way these set up, they just kind of naturally set themselves up easier to use elimination because everything sets up in standard form and you've got, matching variables top and bottom into the equations. Usually elimination is the easiest way, but notice it doesn't tell you how you need to solve them. So if for whatever reason at some point you thought substitution might be easier on some of these, you are more than welcome to go for it. On a lot of it, it's probably going to end up with a lot of fractions at first, but you still would end up with the same answer in the end. Now tomorrow we're going to do some that you'll see when we set them up, they kind of lend themselves more to substitution. So tomorrow's will be a little bit different than today's, but today is very much like yesterday. The only difference is instead of running a negative through it or something easy going away, like the sum and difference problems, on these, you're going to have to do a little bit more manipulation as far as multiplying in order to get something to eliminate. Okay. All right. So if we look at example number 1, again, we're only going to do 2 examples here, so this should go fairly quick. For example number 1, we have high school A renting 14 vans, 13 buses for a total of 567. The layout at least should look familiar. We had 14 vans plus 13 buses, and that held a total of 567 students. And then we look at our next high school, and it had 7 vans and 11 buses totaling 441 students. So we've got 7 vans plus 11 buses equals 441 students. This should look familiar as far as the setup. The only difference here is that we don't have a matching coefficients, right? 14 and 7 as far as our vans, 13 and 11 for our buses. Now, looking at these kind of from a far out overview, the vans are going to be the easier ones to manipulate because I can multiply 7 by something and make it a 14. I can't multiply 13 by anything to make it or 11 by anything to make it 13. So my buses wouldn't necessarily be the easier one here, but I know that I can multiply 7 by 2 and get my coefficients to match. Now, if I leave it like it is right now, I'm going to have 14V and 14V. They're both going to be positive, and that doesn't work. So you can do it in 2 steps. I would do it in 1 step, but we know we're going to actually have to also multiply a negative through. So I would just multiply it by -2 to begin with. And that way you don't have to multiply it by a negative here in just a minute. Okay. All right. So my top equation doesn't change. 14V plus 13B equals 567. I didn't have to do anything to that one. I do have to run a negative through my bottom. So my bottom equation is -14V, -2 times 11, don't forget that middle term, is -22B. And then -2 times +441 is -882. Okay, now I've run the negative through all 3 terms, and I have kind of forced what I wanted, which is that the 14V and the -14V cancel out. 13 minus 22 is -9B, and 567 minus 882 is -315. And when I divide by a -9, excuse me, on both sides, I get B equals 35. And again, I always go back to my original equation or my original story problem, and I look at the very last sentences here. How many students, right? So that tells me that my answer is 35 students. Okay. Now, I just want to kind of head this off at the pass because it does sometimes creep up. If you have a little bit of a glitch and you forget, let's say that 13 minus 22 is -9 and you put it as +9, right? And you divide both sides by a negative and you get the answer -35. You've got to think through what your story problem means. Can you have -35 students? So if you get something wonky like a negative or a decimal, which when I did this second hour, I messed up on one of my multiplication. And so when I got my final answer, it was like 4.823. I knew I was off. Like that was my big red flag. So if you get a negative that doesn't belong, you can't have negative rose bushes or negative students, and you're not going to get any crazy decimals here. So if that happens, just go back and see where you might have made a small error. Okay. All right. So now we know the value of B. So I'm going to come back to one of my original ones, and I'm just going to use the 7V plus 11B equals 441. And I am now going to plug in what I know for B. So 7V plus 11. Now in place of the B, I can put a 35 equals 441. And 35 times 11 is 385. And then when you subtract 385 from both sides, you get 56. So we get 7V equals 56. And then when we divide both sides by 7, we get V equals 8. And again, it's 8 students. And I don't care that they're separated as far as your answer, as long as you square them both, because both are part of your answer. 8 students per van, 35 students per bus. Yes. Nope, because either way, you're going to end up with the same answer. Yep. Doesn't matter if you put them on top or bottom, because when you run it through, you would still have negative 22B plus 13, and you'd still get negative 9. Okay. All right. Let's set up one more, and then we will call it done. And I've got your homework assignment for you. All right. We've got selling tickets on the first day of sales. Let's see, what have we got? First day of sales, we've got 8 adult tickets and 3 child tickets for a total of $47. So that's going to be 8 adult tickets plus 3 child tickets, totals $47 in sales. Then we go to the second day and we make a total of $121 by selling 14 adult tickets and 13 child tickets. So 14 adult tickets plus 13 child tickets totaled 121. Now we're ready to see about solving this by elimination. Now, again, always take a look. I can't make an 8 a 14. I can't make a 3 a 13. So this means this is going to have to be a double elimination. And so I'm going to go ahead and multiply across the top by 14. And I'm going to multiply across the bottom by 8. Now, again, you got to think through this. Right now, as it stands, if I multiply both by a positive, I'm going to get a positive and a positive. So I need to run a negative through one of them. Okay. And it doesn't matter which one. Yes. If you want to find a smaller factor, that's fine. Yeah. Yeah. If you want to find a smaller factor, you can. If one pops out at you, you can. But if you want to do it without even having to kind of think about it, you just use the actual numbers. But yes, that is fine. Do what? Yeah. If you want to change it to 56A, because that's a common factor that they both have, you can do 4 and 7. And either way, you're going to get the same answer. Okay. All right. So multiplying across the top, I've got 14 times 8, which is 112A. And I've got 14 times 3, which is 42C. And then I have 14 times 47, which is 658. So that is distributing the 14 across the top. Now across the bottom, I'm going to distribute a negative 8, which I know is going to give me a negative 112A, because that was the whole point. And 8 times 13 is negative 104 for your child ticket. So negative 104C. And negative 8 times 121 is 968, negative 968. All right, so now we're ready to set it up. As we planned it, our 112 and negative 112 cancel out, which is what we wanted to happen. We have 42 minus 104, which is negative 62C. And we have 658 minus 968, which is negative 310. And when we divide 310 by 62, we get 5. And again, we're dividing both sides by a negative 62. So you do end up with a positive 5. Now, this was the child tickets and its cost, right? What's the price? So our answer needs to have a dollar sign. So there's half our answer. Now we're going to come back to one of these equations and we're going to plug 5 in for a C. So 8A plus 3 times 5 equals 47. 3 times 5 is 15. I'm going to subtract 15 from both sides. And I get 8A equals, is that 32? Divide both sides by 8, and I get A equals $4. So my adult tickets are $4, and my children's tickets are $5. Maybe they're senior citizen adults and they give them a discount. I know every year when I use this as an example, I always think that doesn't make sense because typically adult tickets cost more, but that is the answer. So, and if you ever wanted to check it to see if you were right, you could pick either one of those equations and you could put 8 times 4 plus 3 times 5, and you're going to get it equals 47. So you can check it by plugging in both your variables and see if you get a true statement. Okay. All right. So like I said, this day is very much like yesterday. You're still going to set them up just like you did yesterday, but this is going to be one where you're going to have to use a little bit more multiplication manipulation in order to get something to go away. I will tell you all your answers are whole. You won't have any negatives. You won't have any funky decimals or fractions. So if you get something like that, go back and look at your problem and see where you went off. Okay. All right. For those of you at home, shoot me an email if you have any questions and submit through Cami.